The following short animation is brought to you by Sanofi Pasteur. It explains the mechanism and advantages of vaccination against influenza using an innovative intradermal mode of administration.
Antigens are substances or complex proteins that are recognized as being foreign by the immune system. In the case of influenza vaccines, the key antigens present in the vaccine are proteins that protrude from the surface of the influenza virus. It is the recognition of these key surface antigens by specific immune cells that elicit the immune response. In the context of vaccination, the objective is to trigger an immune response that can effectively protect the body against future infection with the influenza virus.
For the immune system to respond effectively to an antigen, the coordinated actions of several key players are required. Dendritic cells are highly efficient antigen-presenting cells which initiate the immune response and also determine its quality and strength.
T and B cells collaborate to eliminate specific invading microorganisms and subsequently develop immune memory of the organism. One of the main roles of B cells is their differentiation into plasmacytes, which then synthesize and secrete antibodies.
Antibodies are Y-shaped proteins that contain a variable region which binds to a specific antigen. Binding results in the elimination of the bound antigen through interaction with effector cells such as macrophages.
Skin is one of the main immunocompetent organs and is easily accessible, making it an ideal site for vaccination. As a major barrier between the body and the outside world, the skin is constantly confronted with microbial, chemical and physical challenges. Not only does the skin form a physical passive barrier due to its multiple layers, it is also an active immune organ.
Firstly, both the epidermis and dermis contain a high density of antigen-presenting cells. The dermis is particularly rich in dendritic cells, which can efficiently generate innate and adaptive immune responses. Secondly, the dermis has a high density of both lymphatic vessels and blood capillaries, favouring rapid cellular and fluid exchange. Owing to the high density of dendritic cells in the dermis and vicinity of blood and lymphatic vessels, intradermal vaccination is expected to provide direct and efficient access to the immune system.
Delivery of antigen to dendritic cells via intradermal administration permits activation of the immune system. Once the selected antigens that form the vaccine have been injected into the dermis, they are captured by the numerous dermal dendritic cells. As the dendritic cells mature, they transport the antigens through the lymphatic system to the regional draining lymph nodes. Owing to the high density of lymphatic vessels and blood capillaries, additional pathways may allow the antigen to gain access to lymph nodes. Within the lymph node, processed antigens are presented by dendritic cells to T and B cells, activating them. Once activated, the CD4 plus T cells proliferate and differentiate into CD4 plus T helper cells, which interact with B cells. B cells possess non-specific antibody-like receptors on their surface that are able to bind to the antigens presented by dendritic cells. Binding activates the B cells, which subsequently proliferate and differentiate into antibody-producing plasmacytes with the support of CD4 plus helper T cells. These plasmacytes secrete large amounts of antigen-specific receptor as soluble antibodies. At this stage, the main elements of the adaptive immune response are in place. Antibodies circulate within the body, including respiratory mucosal tissues, and remain ready to recognize and bind to their specific antigens, thus contributing to the immediate neutralization of the influenza virus. In addition, antigen-specific memory T and B cells located in diverse lymphoid organs are ready to reactivate whenever re-encountering known antigens. Influenza vaccination via the ID route offers the potential for increased immune response by better triggering dendritic cells and exploiting the direct access to the immune system.
When a vaccinated person inhales droplets containing the influenza virus, vaccine-induced antibodies recognize and bind to the viral antigens. Memory cells also reactivate, producing additional specific antibodies.
Antibodies block the influenza virus from binding and entering its target cell. Subsequently, through their constant region, antibodies bind to effector cells, such as macrophages, which internalize the virus and destroy it. By protecting individuals against influenza infection, vaccination not only reduces the morbidity associated with influenza infection, but also the transmissibility of the virus.
As the leader in influenza vaccines, Sanofi Pasteur is developing the first intradermal influenza vaccine. The vaccine will be delivered using an innovative ID microinjection system. This innovative microinjection technology offers safety, simplicity and comfort with a smaller and thinner needle. The microneedle used is only 1.5 millimeters long and narrower than standard needles used for IM vaccines. This ensures limited penetration to the dermis layer only.
Based on Sanofi Pasteur's technical advances, the antigen volume can be concentrated such that the volume injected intradermally is 5 times less than that typically used in IM injections. The length of the microneedle allows delivery of the exact dose of antigen precisely into the dermis in all adult patients, irrespective of age, gender, ethnic origin and body mass index. Indeed, the dermis of the deltoid region, which is the recommended site of injection, does not vary significantly according to body characteristics.
The microinjection system offers a simple and reliable method of safely delivering a precise dose of vaccine exactly into the dermis, enabling successful vaccination. The microinjection system has been specifically designed to be robust, reliable and intuitive to use. The microneedle is integrated into the injection system, which is pre-filled with influenza vaccine. No specific training is required to achieve successful vaccination.
Another advantage of this innovative system is that the user is protected by an integrated needle shielding system, minimizing the risk of sharps injuries.
Vaccination against influenza is recommended for the elderly by most health authorities worldwide, as this population is particularly vulnerable to the most serious complication of the influenza infection. Immunosenescence, the age-related weakening of the immune system, makes the elderly more susceptible to infection. The current intramuscular influenza vaccine have been proven to be effective. However, clinical trials have shown that the vaccine administration via intradermal route can improve the immune response in the elderly.
Sanofi Pasteur has developed a new intradermal influenza vaccine in order to provide higher seroprotection rates in the elderly population than those produced by intramuscular vaccination, but at a comparable 15 microgram dosage. The results of a multicenter randomized controlled trial in 1100 elderly subjects has shown that post-vaccination geometric mean antibody titers were 50 to 70% higher than those in the control group. This increase in immune response is expected to enhance the protection against influenza in the elderly population. The intradermal influenza vaccine also offers efficient protection in the adult population below 60 years of age at a reduced dosage. It's 9 microgram instead of 15 microgram. Overall, the clinical trials in over 7,000 adults or elderly participants have shown that the intradermal influenza vaccination is safe, even with repeated annual vaccination. Intradermal influenza vaccination using a simple, new and reliable microinjection system is expected to be a promising option for increasing the protection against influenza infection and its associated complications in the elderly population.
As the world leader in the domain of influenza vaccines, Sanofi Pasteur is committed to developing products to ensure enhanced patient protection and comfort.